As we all know, the healthcare industry is typically one of the few industries that's the last to adopt AI. There's many reasons for that, and primarily it's because we're dealing with patients and patient care, that the level of validation and critique used to bring a product to market that impacts a human being is much more stringent than it is for other industries. But that being said, we're seeing now a sea change in how we're approaching AI and healthcare in general. And we believe that this is really due to the paradigm shift on a few elements. And I think the challenges in front of us today within the healthcare industry is really why it is paramount that we use AI and advancements in innovation technology to support us. We all know that healthcare spend is going up year on year. Against GDP, there's no comparison. The percentage of healthcare spend is going up significantly more than the GDP contribution that countries are having. We all know we have an aging population that requires more treatment, more care throughout their life and for longer in their life. And all of these elements are driving up the cost of healthcare. So one of the sort of future visions of healthcare is not just healthcare but health. I think there is a clear distinction between what we call healthcare as we see it today, the traditional way of treating disease and people with disease, and the new way of actually predicting, preventing, and if it goes through those two elements, precisely treating disease as we move forward. So a lot of the work that we do at M42 and the wider ecosystem is looking at, within those three Ps, how do we innovate and provide solution that will support in the prediction, prevention, and the precision of healthcare delivery. So we mentioned this. Healthcare was traditionally a protocol-based medicine. There is a disease, it's been studied and evaluated through clinical trials for medication treatment of that disease. 90% of all clinical trials are conducted on 10% of the world's ethnicities. There's a significant underrepresentation of the vast majority of the world within these clinical trials. So that being said, we're not precisely treating these diseases. It is a volume-based healthcare. We're looking at procedures, billing on procedures. The more procedures I perform, the more money I obtain, and not a value-based healthcare. We should be looking at purely at the outcome of those procedures and that treatment and that intervention. And it was typically a one-size-fits-all model. Again, looking at disease rather than the individual with a disease. So we have to change this, and this is changing. We can see elements of this, but I think there has to be a much more of a global impact and a global change when it comes to the way we approach healthcare and the way we have historically done and how we will do things moving forward. So our journey within M42 of precision medicine, how we see precision medicine is not traditionally just looking at what the genomic data will reveal to us within the life and the personalized journey of the individual, but also one integral part of how the environment is affecting us as human beings. The WHO has the One Health policy, which is basically anything that interacts indirectly or directly with a human being affects a human being. So the question is, how do we build that triangle of data sets and pull insights? How is the environment affecting us as humans? And how is our genome also affecting us as humans? And what is the correlation between the three elements and the three main points there? So I think by finding causative agents within the environment that creates phenotypic changes in us humans, also having the phenotypic data within our ecosystem, be it the health exchange of Abu Dhabi within Malafi, or be it within the medical records within the hospitals like Cleveland, Clinic Abu Dhabi and other hospitals, by bringing all these data sets together and using AI to pull insights, looking at polygenic risk scores, looking at phenotypic risk stratification, we can now very proactively start predicting disease rather than managing disease as we diagnose it. One of the key enablers to this is what the flagship program of the Emirati Genome Program. This is a very unique population genome program that is helping driving a significant amount of data towards this personalized journey of population to precision medicine. It is aspirations, it's a sequence, the entire UAE population, UAE nationals of 1 million individuals. We're currently over 60% within that journey within the first 3 years. But more importantly is translating that genomic data within the clinical practice. We're very fortunate enough to have brought that already within the clinical domain through clinical diagnostics, prevention programs, prediction programs, which we'll describe a bit later on. So if we look at the continuum of genomic testing, now we're taking a slither of what we considered as part of the overriding journey of precision medicine, but we're looking at how population-based genomic screening can inform on the prediction of diseases. So if we can now look at the entire population and find genomic hotspots, pre-classified genomic data sets that says these individuals or this cohort of individuals are a much higher likelihood of breast cancer, as an example. Now we can proactively put them into the healthcare screening system, manage that disease burden or that risk of disease, and proactively deal with this. Now, how are we dealing with these screening programs? We are looking at through age classification, imaging classification, and blood testing. By having a whole genome of a newborn and understanding their risk to cancer and diseases from newborn, this is a paradigm shift in how we approach proactiveness to prediction of disease and managing it. So this is one of the elements, and we described here the premarital screening. As of the 1st of October of this year, premarital screening became a mandated program for all UAE nationals getting married in Abu Dhabi. So now we can see all the hidden diseases, not just the known diseases of risk. By bringing these two genetic pools together, the male and the female, in this union and marriage, we are now looking at all the autosomal recessives. They don't have a disorder, neither does their partner have a disorder, but them joining their genetic pool together will have a 25% likelihood of their offspring having a disorder, a rare genetic disease. So if I'm able to inform that couple of the risk of this marriage, while not stopping them from marriage, but if they continue with the marriage, providing them IVF solutions to choose a healthy embryo, then imagine now you have stopped and eliminated rare genetic diseases before it even happened. That's the true idea of prevention. Rather than just screening people and looking for diseases and trying to catch it earlier, we're actually stopping a disease happening before it even happens. So this is the foresight. We're looking at 840 rare genetic disorders within this program. Newborn screening is another example, proactively looking, as I described previously, the genetic disorders of a newborn, while we have the whole life ahead of us to manage and anticipate those disease burdens and manage them throughout the healthcare ecosystem. Predicting healthcare spend, looking at how we can reduce the cost and optimize the way we spend on healthcare, because we know now what diseases we will be burdened with and when we potentially will be burdened with these diseases. The population genome screening program is what I believe truly is the revolution when it comes to genomic screening. You take an entire population and you're building a whole disease predictive modeling on top of the entire population. And because the healthcare ecosystem is available, as I described previously, we will be able to now start predicting disease way before it happens. We're looking at a multi-omic approach, not just genomic, but proteomics, transcriptomics. Our genome is what is our blueprint, but eventually that genome transcribes or builds the proteins that make up the physiology and the makeup of our human being. And there could be mutations, issues with interpretation. And so if we look at our proteins, we can start now predicting disease as well. That is affected by the environment. A prime example of this now is that when we're looking at proteomic analysis, we can see that looking at cardiovascular disease, by looking at 6,000-7,000 different proteins within a blood sample, we can now predict a heart attack 4 years before it happens clinically. So if we're able now to predict and stratify the risk of a heart attack 4 years before it happens, and proactively manage the lifestyle, the medication of that individual, and reduce that risk of heart attack or cardiovascular disease through their protein analysis and measure that over time, this is again a revolution in the way we treat and manage our population communities. The main purpose why AI is critical in the way that we analyze our data is because of the mass amount of data that we see. One whole genome it sits on 3.2 billion data points. That's one human being's genome. So If you took a small biopsy, like we do in the hospital these days, a small biopsy to look at any potential risk of cancer, tumor, benign or somatic, that one tiny little biopsy could have up to 44 million separate data points. So for us to really integrate, amalgamate this data set and build much insights from it, we need the tools of machine learning, large language models, because this is humanly impractical to pull the insights. Genomic analysis, whole genome sequencing started about 50 odd years ago. It costs millions and millions of dollars. We are today now doing genomic analysis costing us $100, and within 3 or 4 days we can get a whole genome. But the reason why it took us years and years of progression is because we didn't have the technology to innovate and expedite. Today we only understand 5 to 6% of the entire whole genome for clinical applications. So imagine 50 years of hard scientific expedition and discovery, we only understand 5 or 6%. So we truly need the innovations of expediting, using the tools that we have available through us, through the AI models, to help in expediting that now, moving forward exponentially. So in the next decade, we can understand 50, 60% of the genome. What will it, if we only understand 6% today, imagine we understand 50%, how much of that impact that could have on the population as a whole. Again, we looked at every single vertical from risk assessment all the way into therapeutics and monitoring, and I won't bore you with every way AI can enable this, but AI can really enable every single one of these verticals and expedite the development of these verticals. One small area that I think we can slightly double click on is pharmacogenomics. We currently launched pharmacogenomics within Abu Dhabi, whereby every single Emirati Genome Program participant will have their pharmacogenomic report on Malafi at some stage in the near future. Now the question is, that's great, you have the pharmacogenomic report accessible to the entire healthcare ecosystem through a health exchange like Malafi. But the question is now, how do we build insights of that pharmacogenomic report? How do I proactively ensure that a physician orders a medication that is right for that individual and personalized for that individual? It will be for the first program in the world that will allow the entire population to have a personalized pharmacogenomic report within the health exchange within their country. So now using Med42, our large language model, it can start telling the physicians on the insights that are generated from the pharmacogenomic report, as advising the physician on the latest guidelines on PharmCat and other international guidelines on how to treat this particular condition for this particular individual with that particular medication. That's a true essence of personalized medicine, where you go from a disease to the individual, from the individual to the medication, and from the medication back to the individual and how they actually metabolize and use that medication. I made that claim earlier of 90% of the world's clinical trials are conducting on 10% of ethnicities. So what impact does that have on the pharmacogenomics? When I take a statin, does that statin work on me? We don't know, because at the end of the day, this statin was, the clinical trial conducted to bring that statin to market was probably not conducted on a person of my genetic pool. So it's critical now that we bring this back to the patient, again democratizing genomic complex data directly to a physician and a patient as well. Another small example of how we're using AI into discovery within clinical genomics. As we know, we can discover many variants, many different changes within our genomic makeup. And these variants, the way that we classify them today is we scour the internet for well-reputable medical publications to understand what we consider the classification. Is this variant going to cause a disease? i.e., is it pathogenic or is it likely pathogenic? And it's debatable. Our scientists, which are highly specialized resources, sit daily and debate this and look at all the publications globally. And that's why it takes weeks and weeks to issue a detailed clinical genomic report. It's not about the sequencing capabilities, that takes a few days. It's about the interpretation of the genomic data. So if you have an AI-powered tool, a large language model that scours all the databases in the world and looks for credible, has very stringent criteria, and looks for credible publications that can easily and quickly define the classification of that variant, then we can easily start identifying much quicker the diseases that is in our communities at a much quicker rate. This can become somewhat of a stat test. Today, it's a test that you wait 2 months or 3 months for. If I can get a result within 2 days of a whole genome sequence using AI, that's where the AI-powered innovation comes in, bringing genomics directly to the patient. And lastly, I would like to finish off what we feel is, again, we believe that we need partnership. We need really technology and innovation to bring this not just to the UAE, but to the world. So we're very fortunate as M42 that we sit on a lot of data sets. We hold a lot of biological material. We just launched this year the Abu Dhabi Biobank, where we'll be holding not just the data itself, but the biological specimens itself. Creating this innovation hub, bringing people local to the UAE is what's critical to our mandate. Localizing the know-how and the scientific abilities, and then also bringing that to the world as well. We have done here some remarkable advancements when it comes to genomic and AI applications within population and precision medicine. And we feel now collaborating globally and bringing all these environmental and data sets and genomic data sets and the medical records all in one place will expedite what we feel is the discovery part of our journey. The future of healthcare is about bringing healthcare directly to the patient, transforming healthcare from a transactional-based solution to a value-based system. The only way to do this is that we have all the information available to us in a decentralized manner and directly available at the fingertips of our physicians and our patients and our population. So thank you so much for your time.